around and talk. So let's get started. Ground truths of a rugged DevOps practitioner. So who am I? I'm Matt Tesoro. I've been at Rackspace since 2011. Myself and another person started the product security group, which is now called the security engineering group, and probably next week will be an unpronounceable symbol. And I work with the QE and developers. We're actually in the product development group. Do I need to? Yeah. That's okay. Is that consistent or better? Yep, that's better. Okay. We should be consistent and better, even if I'm never this formal, but that's okay. I can live with it. So that's the work side of me. The other side of me is I am very actively involved in OWASP. I was a former OWASP Board Foundation member. I've got a couple projects that I lead with OWASP, and I love AppSec. We good or be bad? Like, here, let's let a professional do this. Is that better? Ah, okay, yay. So now you can consistently hear me. Let's move on. So let's get into it. So I'm going to do like the 3-second overview of after what 4 other things of DevOps. I'm not going to explain this, but you guys get the idea, right? It's the whole stop the wall between ops and devs. Everybody gets together. It's all fun, cultural, people, process. We got all that. I'm skipping this slide, but I've done this in isolation before. And then just if I throw these acronyms, CI, continuous integration, CD can be continuous deployment or delivery, depending on who's talking about it. TDD, test-driven development, for those who may or may not have heard of it. And API, application program interface. Right, done. Level set. Let's move on. So the problem, and this was alluded to in several of the talks today already in this room. Right, cycle time for software is getting ridiculously short. And my crazy example I like to throw out is one of our teams at Rackspace last year, their average deploy to production in a week was 75 times. So like by week of scanning, that is the traditional I'm a security dude, is non-existent, right? It's my 3 minutes of scanning or something crazy. In Rackspace, particularly, like continuous delivery is a goal. And so those scanning windows are gone. Like that whole model is thrown out the door, right? And even if you're trying to, and you're holding on hard to your traditional security mantra, like you're going to fight the business because the first mover advantage is going to kill you every time. Because you will be seen as an impediment and you will be worked around, right? So this is like the old school way of thinking about security, it just doesn't work. And I had a little bit of this before Rackspace, but Rackspace really drove this home for me. Like any of my old sort of thinking of, well, I need the week to do the test was like, done. Like, no. We gotta find another way. And then at Rackspace, we have tons of DevOps, agile, continuous delivery, which is even making it worse. And even more at Rack, we have tons of Python, which means a lot of the automation, particularly in the static analysis world, is also out the door, right? So it's just like, even when you think you might have a chance, you get that low body blow and you're knocked over. And then even better for our group, we have tons of RESTful APIs that don't bother even with a, what is it? Oh, a waddle. We don't even do the waddles, the description of a REST API. So we can't even programmatically interface with them, right? And there's no good tools that I know of that really do fully automated REST testing. There's some that do an okay job, but you really are limited to doing it manually, right? Somehow. So this is once again another artifact of the fact that like traditional testing, done. So what do? You automate like crazy. And that's what we've done in the product security group. Oh, well, I'm going to say that all day long. Security engineering, whatever we call us. Automated software testing, automated operational infrastructure testing, and automate security testing. So let's talk through those guys. Oh, the other thing. Like the other thing that my first job out of college was a developer for a international telecom who, oddly enough, their data center was in a small town in Texas. Really hard to understand because almost all of our operations were in Europe. But so a lot of the security people I'm running into don't actually, I'm fortunate. I started out as a developer. It's easy for me to think like a developer, but you really have to think like a developer and figure out what tests you can chop off and run sort of a la carte and mix and match, right? Like a normal infrastructure test is really a whole ton of little tests all jammed in together. Well, which ones of those can I automate and break out and separate and maybe do as a regular interval as opposed to on a scan window? And then you kind of have to be, well, you kind of have to be a little bit smarter. When I was a consultant and doing just traditional pen testing, as long as I got the engagement done and the time window that the engagement was in, we're good. So if I had to like sort of knock up some quick and ugly Python to do something, if it wasn't particularly optimized, it didn't really matter. It just had to get done before the engagement window was done. But if now we're doing these things on a repeated cycle, you actually have to write decent, reliable code, right? It needs to sort of be optimized. You can't assume that you're going to get a long run window. And then try to think about the idea between like a smoke test and a regression test, right? And I like to think of a smoke test, the test early and often, is like you must be this high to ride the ride, right? Like, I want to get as much of that automated as possible. No, it is not perfect security testing, but it's a lot better than getting no testing done because you want to be a purist, right? So we've found a lot of things at RAC where we can sort of determine you're at least this high and you're cool to ride the ride. And then maximize what you got. Like, this is another like funny thing that you can get tons of traction for very little cost. The perfect example, we have a lot of Django apps knocking around. Well, Django apps is a Boolean true-false for CSRF protection in a config file. Like, this should be something you can write against GitHub if they check in a Django app. I mean, that's greppable, right? In that file, is this turned on? No, fail. Like, that's a 3-second thing, right? And yes, I mean, static analysis by grep isn't cool, but it really works in some of these cases. So if you understand your frameworks and what security or options are there to begin with, you can actually get tons of traction really quick. And this is something that you can make a check and hook, right? The minute I check in my first Django thing, you can fail it. It goes red. And then you have to make the tests repeatable and easy to understand because, quite honestly, I've been fortunate the last chunk of time I've been on one project, but usually we're bouncing between products. There's way more products than there are security people at RAC. So I may be testing cloud servers one week and cloud databases the next. And maybe the next time cloud servers comes up, it's another person on my team. He's got to be able to run my tests without a lot of interaction on me, or else we're all slowed down. And then this is where the Unix philosophy of doing small, simple things that do one thing well, you really have to make your security tools do that, because then you can really start this a la carte mix and match, right? Simple little tools that test one aspect of security, then you can start deciding how many of those I can combine within my window. Because like I said, Rackspace, we have the crazy fast, and we have a lot slower. There's a spectrum of what I see. And so maybe for some groups, I can do all, let's say 50 checks, the automated checks. Because their timeline is a 2-window sprint, and it's a little bit slower, and I got some breathing room. For those faster groups, maybe I can only pick the top 5 that are really risky for this particular type of app, and I run those. So if you don't have these things mixed and match and combinable, you're sort of doomed to begin with. Right? So these are just good fundamental principles when you're doing this testing. Now I need a drink. Test-driven security. So I like the idea of test-driven development, and the idea where you write tests and you're failing, you write code until the tests pass. This is the same idea, but with security. So with test-driven development, right, your code works when your test passes, and you write your tests first. In my mind, test-driven security, which is kind of DevOps security as well, you know your app has made or met a security baseline when it passed the tests. And security baseline is really key. I mean, I've had arguments with fellows in this industry who are very much a purist, and oh my God, you're not testing all 833 variations of everything. Well, you know, that's cute. I don't have time for that. And there's 100 things that I really, really care about. And maybe I'll do those up front. And maybe once it's out on production, I'll check those other things. But you know what? The other nice thing about that really fast cycle time, if I find a problem, it gets fixed fast too, right? So I bet you money in a lot of cases, if you have a fast cycle time, even though it is exposed in production, that window is shorter than if you don't have a fast cycle time, right? So there's actually the wonderful case, that same really fast team. One of my other coworkers was testing it. He has an IRC window open with that team. He's testing them. They're out in California. We're out of San Antonio. He's testing. He finds an issue. Jumps in the IRC channel. Hey, guys, I noticed I can do this and I shouldn't. Oh, what does that look like? Oh, here's what I did. Here's the curl, whatever. OK, cool. Let me look. Goes back to testing. Gets a ping on the IRC. Hey, it's fixed. Like what? He didn't even have time to write up the finding before it was fixed. So yeah, the speed stuff is crazy, but it can also work for you, right? It was kind of like, so we ended up having to write a finding and close it. Like boom, boom. So it's time to mourn. Like, traditional application security is dead. Like, if you were doing it, you just might as well plant it and move on. And we did hardly know you. It's such a nascent industry. So I'm going to talk about the 5 stages of grief. What, back one? I can back one. Yeah. No problem. Yeah, I love those generator things, man. You can have all sorts of fun with those. So let's talk about the 5 stages of grief, and you can find out where you are in the spectrum, right? Denial, right? That agile thing is a fad. This DevOps thing is a fad. It's never going to catch on. It's just crazy. Waterfall is the only way to produce quality software, right? And there's still some people out in the world that firmly believe this. God help them. Right? And then anger, like there's no way I can test that in time. Like if I see another freaking sticky note on the wall, I'm going to go loony and like just run down the halls and be crazy, right? Or maybe bargaining, right? Well, I think I can test some of it in 2 days, but I really need 5. But so you won't get a full test, you know, and we can do it after it's deployed to prod, I guess, and we'll give you an exception, and all this bargaining happens, right? And then depression. Like after that launch, I updated my LinkedIn profile. Like I'm done. Right? And then aliens, right? Game over, dude, game over, right? And then acceptance. This is where you want to be, right? So when can you add that story to work on that regression, right? Hey, I need this to be in the next sprint. What can we pull out of that sprint and add in this thing? It's actually a high priority issue, right? We looked at your deployment recipe and we took a PR, a pull request, to change your salt stack, or I forget what salt calls their things, your Ansible playbook, right? To harden that server a little bit, right? These are the conversations you want to have, right? So I'm going to talk about these 3 areas to get you from denial into acceptance. And these are things where I broke my knuckles at RAC and other people on our team broke our knuckles at RAC. But we've actually gotten a lot of good traction. So let's talk about securing the infrastructure. And we kind of break stuff down into infrastructure, apps and APIs, and code. That's just kind of works well for RAC. I think generally this would work for anybody. It kind of depends on what your environment is. But for us, those are kind of the 3 big key areas. So infrastructure, right? Hopefully you've got Puppet, Salt, Ansible, Chef, something automating your deploys and your infrastructure, right? These are all over RAC. Unfortunately, I see Puppet, Chef, Ansible, Salt. At RAC, I see them all. I haven't seen CF Engine, but there's probably some somewhere I haven't found yet. But we've got them all. But these are great things. And as a former sysadmin, one of my hats was a sysadmin. I wish this had existed when I was managing servers, because this is really cool. Like I know that when I launch that server, it looks like the last one. That's awesome. Everybody know Chef, Puppet, Salt, Ansible. Do we know those? We understand what I mean, right? You have an idea of, you have some sort of sysadmin writing some sort of something. It gets pushed out to nodes. They get configured accordingly, right? And there's different modes, and this is Chef, but whatever, right? And you have cookbooks, stacks, playbooks, whatever you call them, right? And it's some sort of way to say, this is what I want the end result to look like, in however your particular technology wants to do it. But the thing here from a security point of view is 1, all of those things are the same, right? 2, like if I read through this and I understand how it gets deployed, and I can suggest fixes, those fixes happen to every future deployment, right? Anytime you launch a new API node, if I've made a change or a PR and fixed it, all new API nodes will have that change. So this is a huge place that you can put a little bit of time and get giant win. Like one of the product teams was using Salt. They spun up a couple instances of each of the different types of servers they had. We did a VA pen test against them. We found a few things. We fed them back to the team. They updated their Salt stacks, redeploy, done. Right? This is like a great way to get tons of traction. And if you want to be really nice, like some of these things you pull off the public repos are scary, bad. If you want to get some karma points, push them patches upstream, right? And get a hardened Apache, not just like, hey, port 80 works. And then the other thing you can do with most of these technologies is do some sort of tagging, grouping, sorting, right, of these types of servers, right? And you can have different roles or what have you. And the tagging is usually done to apply like what's required to happen to that server, right? A web server should have Nginx installed in it. A database server should have Postgres installed in it. A monitoring server will have whatever installed in it, right? Well, take those tags or roles or what have you, and apply a security policy to them, right? Because the Puppet Chef Ansible Salt has already told you what its role is, right? And you have an understanding of the risk of that system in the app it is. You can apply policy based on those tags. If you're really smart, you can read those tags out of the repo and actually talk to the servers in the same way, right? Like, you know, I can get a list of all the database servers and I can check them for database things, because in the repo that has the Ansible playbook, well, the Ansible config, it's all listed out, right? And then an inspector. This is a really cool idea, and we've done some of this. I haven't done it as much as we'd like. So for each group or tag or category, role, what have you, review the recipe and hook the post provisioning so that you run your own bit of check. And the idea is, like, think about when you build a house, right? You have an architect who designs the plans, and you have a builder who builds the house. What do you have, hopefully? An inspector that comes in and makes sure everything's to code. This is the type of thing you want to write, right? Because now, when you do this, every time it's built, you have a way to go back and check. Hey, I just popped a new WordPress. Let me go in and make sure it looks like it should, either from the inside or outside, right? As an external scan or maybe an internal look. I did this with our container team. I've been working with there's a container team building an internal use LXC container product at Rack. I actually wrote a bit of shell script because it's a very minimal OS we launched. So I wrote a whole bunch of SH that would go in and check 126 odd things that we cared about, like, is this on, is this turned off, etc. And I wrote a bit of Python to automate that in Jenkins so that for every check-in of the container service code, I pop a new container, I drop my SH in there, I run it, I pull a report, I blow away the container. And we've actually found regressions in our code based on me running this, right? And this is, to the developers, just as another Jenkins job. And like, oh crap, it's red, let's go look, right? So I may be a security guy, but I think to the containers team, I'm just like another team member, which is a pretty cool place to be. And then an agent. Yes, another important thing. So particularly at Rackspace, we're a cloud company. We have lots of cloud servers, right? Things come up, things come down, environments go up, environments go down. And when you don't have long-running servers, like the traditional way of scanning them or having something, this doesn't work. So drop an agent as part of that standard deploy. And then that thing can, in essence, be your NARC, right? If the server gets out of compliance or whatever policy you care to apply to it, right? If you are doing this, writing an agent that's read-only will help you sell it to sysadmins, right? Because if you have an agent that can fiddle with stuff, that's really not well taken by system administrators, so read-only is a huge plus. And then you just look at the state of the system and report back to the mothership, right? You can take that and make a dashboard out of it. I remember when this is probably 2 years ago, when the Jenkins vulnerability happened that was pretty ugly. We didn't have this in place, and we did the mad scramble to find all the Jenkinses and then patch them and check them. And how cool would it have been to have agents on all those things, turn them all red, because we update the policy that Jenkins must be greater than X. Board goes red, you find out what team has them, you make some, a few emails or conversations, and you watch the board go green, right? This is the kind of really cool stuff you can do with somebody on the box who's sort of letting you know the state of that machine as it's running. Yes. There's a couple different things you can, like Cloud Passage is a commercial company that sells an agent that's actually pretty slick. Mozilla wrote this thing called MIG. It's Mozilla Investigator. It's actually more for checking the hashes of binaries on the system, but I've thought about co-opting that to do other things because it's pretty nice. And there's another tool called Linus that does a whole bunch of security checks you can run inside of a Linux install. Oh, and then turning vuln scanning on its head. This is another thing, right? So we do tons of threat modeling at Rackspace, and I kind of cheat when I do threat modeling because I have a bunch of people in the room that know what the heck is going on with the system. I not only do the traditional data flow diagram thing, I find out what technology they're using, what underlying OS, et cetera, get all the metadata about that application we're threat modeling. We take that, dump it into a DB, and then, and I've done this at previous employers as well, you subscribe and parse the announce lists or the security lists. Right, and if you want to do this for super cheap free, Gmail plus filters will get you there, right? Or there's commercial things like AppSecUSA Vim that you can pay for, and they'll do the managing of who and what for you. They have like 40K products. But the idea here is now the conversation is, oh, by the way, that product's been out in production for X period, X months. We finally got around to your quarterly scan. Oh God, all this stuff is really out of date and has been for months. We have to mad panic and get it patched, right? Now it's like, hey, guess what, guys? There's a Tomcat vulnerability that just got announced today. We got to get this in the next sprint or two. How are we going to get that done, right? It's a totally different conversation with your ops team, right? Now it's not a, oh God, mad panic, run around, international sign of panic. It's a like calm conversation about how can we roll this out in a sensible way so that no one has to like spend a weekend of heartburn, but we still get the thing patched. And I love the fact that reverses the mug, because like when you proactively go to a team and say, hey, by the way, something just came out today, right? I know you got this. How can we get this fixed over the course of your, like we're going to have to inject it in your normal work, and there'll be some interruption, but it won't be a, oh God, weekend, stay up all night thing. That's a huge win when you're interacting with other teams, because you're usually unfortunately, the guy who causes those jokers to stay there over the weekend. Okay, that's infrastructure. Securing apps and APIs. Oh yes, oh yes. So PDFs are great, bugs are better. And there was an allusion to this earlier in the same track. I did consulting for a while as a pen tester, and I wrote lots of formal reports. If you've ever talked to anybody who did pen testing, they bloody well hate writing reports. And I don't blame them, because most of them don't even get read. What we've done at RAC, and I've done at other places, is I don't write reports anymore. I submit bugs into bug trackers. That's it. Done. Like, there are no reports. Because I take that back. Occasionally management wants a report for political reasons, and then you gen one, but otherwise there are no reports. This is awesome, right? What are the developers used to working with? Bug reports, right? This is cool. I would highly recommend creating, if it doesn't exist, a security category so you can distinguish yours from general functional bugs, right, when you're pulling reports. And bonus points if your bug tracker has an API, because then now you can automate this, right? Done with test, push to bug tracker, done. Right, because you don't want to be copy pasting. That's not cool. Although it is part of the traditional workflow now of the developers, the one thing you have to watch out for is death by backlog, right? You get the project manager saying, oh yeah, we put that in our backlog, we're going to get to it, and it just dies there, right? So this isn't perfect. A lot of times I've had good luck with teams sort of talking them into an occasional security sprint. Like, you have a lot of medium, low vulns. None of them are super scary, but let's like talk about maybe 2 sprints from now doing a security sprint. Let's just kill all these little silly, low, medium issues that are sitting in your backlog. That's been pretty good. And the other thing is you have to learn how teams treat issues, because you have to talk in their language, and unfortunately some of ours are backlogs, some of them are issues, some of them are, they're all over the place depending on the team, so you just have to sort of learn and adapt, unfortunately. And for metrics and pumping issues into issues tracker, ThreadFix is very good. Dan Cornell did a talk earlier on it. We use it at RAC. It's quite a nice thing. I would highly recommend it. And it's just getting better all the time. We actually developed the version 1 integration for that, because it wasn't there and we have that. So, and then for the reticent, yes, nag. So what we did at Rackspace is for every one of our security levels, there's 5 different levels, we attached an SLA. And an SLA isn't getting it fixed, it's getting a remediation plan in place. So for our most scary issue, it's 24 hours to have a remediation plan in place. And that plan may be, oh God, we have to completely re-architect this thing and it's going to take 6 months. Or it may be, yeah, we push this patch next week and it's fixed. But it's a plan, right? Because unfortunately, if you try to do SLAs for getting it fixed, like, you never know the scope of getting it fixed. That's really hard. But generally speaking, management is cool if you know it's a known issue, they're working on it, it's in this sprint, it'll be done at this period of time, we can go back and check with them, right? Then you're good. And then what we do is we age all of the bugs that we have in ThreadFix against those SLAs. We start off with polite warnings of like, hey, your 3-week SLA is getting kind of close, right? Start maybe with the project manager, depending how your org structure is. Start with the project manager, and as it gets closer, maybe you start walking up the org chart. Okay, head of development, by the way, these 3 teams have these long-running issues that are past their SLA. Might want to have a conversation, right? It'd be nice if you have a dashboard. We actually kind of use ThreadFix to be our dashboard. And I would definitely recommend getting management buy-in first, so you don't get political backfire when you start walking up the org chart. right? You definitely want the manager to say, hey, I agree to these SLAs, management. I agree to the SLAs, and I agree to them sort of be gently nudged, if you want to be political, into compliance, right? When you do this, it's been fantastically useful. Reports equals findings plus automation. This is another huge thing where we've had a silly increase in throughput. So we happen to choose ASCII doc. I don't really care. Pick a markup that you like, plain text, because most of your security people are very fine opening up Sublime or VI or whatever and knocking out plain text. They don't like particularly opening up, I sure don't like opening up Word and making fancy documents and worrying about formatting. That drives me nuts. So pick a markup that you like. Pick a standard way you want to write your findings. Use something like pandoc, which will convert almost any markup into almost any output. And now you have a way to generate reports very quickly. Oh, and by the way, now you have report as code almost, right? Check in your reports into a private GitHub repository, and you can actually do diffs on reports. Like, isn't that kind of cool? That's kind of cool. Like, I have one report I have to send a PDF on a regular basis, but another one, they want an email. Same content, you generate one as a PDF, you generate one as HTML, you copy and paste it into an email, you're done. This was huge for us. The cool thing too is, right, the testers are writing the least amount possible. And we actually wrote a little Django app to take these, the Django app that, let's say that we've never done any testing before. We find a cross-site scripting. You write the title, you write the description. Cross-site scripting is blah, 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 right? That's in every finding block. But you don't need to write that but one time. So our Django app, the first time you have a new type of template or type of vulnerability, it saves it as a template and you can reuse it next time. And only things like impacted systems and the risk changes based on the context of the finding. Now your guys are writing only what systems are impacted and maybe a little bit of changing of the risk based on context, but that's it. Right, so we've gotten crazy higher throughput doing this. We started out using Dratus. Unfortunately, Dratus doesn't enforce, say, correct syntax of markup. So you'd pull stuff out of the Dratus database and try to gen it, and it would blow up the markup engine. So we've now abstracted all that into a database. And then we can just gen the markup instantly, which is really cool. Because the other thing you can do is if you have one finding that's particularly problematic, and you want to get it to the team fast, you type it up in the form in our Django app. You say, show me this in ASCII doc, you copy paste it, done. You have a finding instantly just for that one block, right? Or you take all of the findings for an engagement and you have a report. Or you take those findings and you jump them directly into a bug tracking system, right? Because I've abstracted all the bits of a normal report into atomic pieces, and now I can shift and move them around as I need. And this gave us huge throughput bonus. Leverage existing consistency. So if you can find, consistent, particularly computer-generated output, use that, right? Find those, write some scripting, and I'll give you examples. This is a way to automate the drudgery and get rid of the silly paper cuts that make you hate your life. So we automated finding and bug submission. I've kind of talked about that already, right? You need that. You shouldn't ever have to be typing something into a bug tracking system ever, right? Or you're doing something wrong. Automate PDF report generation. I talked about that with our bug tracker and using ASCII doc markup, right? If I need to make a formal report, it's a database query and a call to pandoc, and I'm done. API documentation to basic test harness. This was beautiful. This is one of my coworkers, Michael, did. So OpenStack does not produce waddles, so there's no programmatic way to understand the methods exposed by a REST API from OpenStack, which is annoying when you actually want to test it, because testing it, you usually have to write a little bit of stub methods to make all the method calls to understand what's there, and then you can start playing funny with them, right, after you can actually talk to it legitimately. So Michael wrote a tool that would go out and, I should back up. The OpenStack documentations are programmatically generated, right? The docs.openstack.org are programmatically generated, sadly enough, based on waddles. I got 15 minutes. Okay, cool. I will move faster. Anyway, he wrote a bit of Python that reads that HTML of the docs page, creates stub code for all of the method calls, and done. Now, yes, it's not functional code, but it gives you all of this, scaffolding you need to get that done really quick. That was a fantastic idea. Another really cool one for reflective cross-site scripting, we handed the developers a static web page with links. Done, right? Click on these things. If you don't see an alert box, you fixed it. If you do see an alert box, keep working. And when you get no more alert boxes, talk to us and we'll check it again, right? Like it stops at like, I fixed it, no you didn't, I fixed it, no I didn't, which is evil. Oh, and then I've written a couple tools to take and combine different security tool output into our standard format, right? So if I run Nessus and Burp and something AppScan or something, I can take all of those, jam them into our normal workflow, and done. Okay, securing code. So, start with the developers. Like the findings that you write, this is my mantra to my people, have to be detailed enough so that in 6 months from now I can reproduce this finding, right? I don't want like, I did something and badness happened, right? That's not useful. It has to allow QE or security to be able to test and fix that issue and not you be the QE or security person testing it. And then give enough information for developers to actually fix this thing, right? Like a link of a CS or a reflective cross-site scripting is not particularly useful, right? Here's where you can do like we send a lot of quick and dirty scripts that exercise that vulnerability to the devs. So I found a way to take out one of our APIs with a particularly crazy call. I wrote a little bit of Ruby. It was like 20 lines of Ruby. Here you go. Run this thing. It'll take your API offline, right? Do it in staging. But as you think you have a fix, run this again, right? And when the thing doesn't die, when this thing runs, then we're probably good. And come back and talk to me and we'll retest. Like those, oh, here's the reflective cross-site scripting one. I jumped the gun on that one. And then Gauntlet is another great tool for this, which has been mentioned here a couple times already today. An interesting thing for us, once we really had this going fast, we had interesting training requests like, hey, our group is getting hit by these things a lot. Can you give us some training so we don't even talk to you? I'm like, hey, yeah, we'll do that. Be happy to. Okay, and then cherry pick what you look at, because you will always be resource constrained as a security team anywhere. I don't care where you are, right? We do, like I said, tons of threat modeling, and we use that to sort of guide the testing efforts and the areas that happen with whatever app we're looking at. So focus on weak or weird or suspicious areas. If there's any sort of threat boundary jumping, if there's any kind of transition from XML to JSON or format changes, right? Look at those areas, and that's where you focus your time, right? Because you won't have enough time to do a holistic one, more than likely. So find the scariest bits based on your threat model and really focus on those. Maybe you get lucky and they don't take as long. You can look at it a couple other pieces, but probably not. And then if you have code changes in those areas, OpenStack, by the way, has this idea of like a +2. So if I want to submit a code change to OpenStack, I have to have 2 developers +1 it, and I get a +2 and it goes. Maybe for those scary areas, it's +3, right? Okay, I know these parts are particularly sensitive. Like they're the ones that manage the keys for this app. Those need a +3, and you can hook that all up in Garrett, right? These have to have a 3+ votes before they get integrated, right? That's another great way to sort of help them get a little more rigor. There's search features, like we have an internal GitHub instance. That search feature is ridiculously useful to find lots of stuff. And then we've started sort of gathering a list of problematic calls or things that are greppable, and then just start grepping for them. And probably the best thing about this approach is it's organic, right? You find one problematic call, fine, you grep for one thing. You find 2, now it's 2. And in 6 months, it's 87 things, right? Like the systems that can be built organically are really the systems you want to build, because you're never going to have time to build it fully, but you can always add a little bit over time. Yes. Oh, and no false positives, right? Even if you can automate code review, you have to triage it, because I think I don't know that there's any like mathematics behind this, but I would bet you that one false positive in terms of cred points is worth about 100 valid bugs to a developer, right? I mean, the minute you give them BS, they will call BS on you and they won't talk to you again and they'll think you're an idiot, right? So you really, really have to make sure that that is an actionable item that you're handing over as a finding block, right? And then stick to diffs. I've already sort of talked about this, right? Threat analysis, scary bits, code diffs, those are the things you look at, right? So maybe in the sensitive piece of code or the sensitive app, I look at the code diff of a pull request and it changes the CSS color. Done. I'm not looking at you anymore, right? And that's really easy to do if you do it at a diff level as opposed to a release level. And you just need to build cred points with the dev teams. And you certainly won't have that if you're giving them false positives. Or God help you, you ran Nessus, you printed a report, and you handed it to them. Because I could probably train a monkey to do that, right? That's not really cool. And where's your value add? My value add is what? I click next, and I click print to PDF. Like, that's no value add there. Value add is the only stuff I give you is real, and you actually have to do something about it because it's an actual vulnerability. And quiet is better than wrong. Yeah, definitely. So hire or befriend developers. We tend to hire developers that have a security interest, not security people that have a development interest, because it's easier to speak the language. You know, if you can go in and say, hey, I need to do a PR on this change because the last time you did a deploy, and if you're talking shop with the dev guys, they will listen to you. If you're like, ooh, bad, I need help, here's a big 500-page PDF, you're done. And another key thing that took me a while to realize, quite honestly, in my years of security work, is you suggest requirements, not implementation details. And although this wasn't me, this person's action was the one that made me think this. One of our compliance guys told another team, one of the product teams, you must install Tripwire because of PCI. And this guy came to me because I had an existing relationship with this product team. He said, I hate Tripwire. I want to do OSSec. What is this crap about Tripwire? Does PCI say Tripwire? And I'm like, no, it says host-based intrusion detection. OSSec meets that. If you like that, that's a requirement. You're done, right? So don't make a technical recommendation. It's a requirement. You must have something that does X, right? Not you must install this piece of software that I happen to like. Unless there's a corporate mandate, I guess, but not much of that at RAC. And then mitigation suggestions need to be generic or in the language that that app is in. Because if you send a Java code example to a Python guy, he'll laugh at you. This dumb idiot doesn't even know I wrote this in Python. He sent me Java. What a bozo, right? Like, make it generic if you don't know. And I've already mentioned this before. Fast deploys mean fast fixes. So yes, maybe if you are having a continuous deploy that happens rapidly, yeah, that's kind of scary. But that also means that when you find a fix and you get it in the pipeline, it goes out the door much quicker, right? So this isn't all gloom and doom and like death and drink poison and die. There's actually some good parts to this, right? Okay, so what's Rackspace Security Engineering doing? That was me postulating. Now, what are we actually doing? So, I already said this. Rack has Chef, Puppet, Ansible, Salt, and whatever the next coolness is, we'll have that too. We have Docker. We have everything. Whatever's next hip.io thing, we'll have it. But for those kind of configuration automation scripts, we review those deployment scripts ahead of time. We actually do an audit of those deployment scripts for the teams. We validate them with external vuln scans, and we recheck after bug fixes. We actually had one team that was agile enough and was launching on public cloud that when we wanted to test, they actually threw up a shadow production instance. It really wasn't a production instance, but it was their production code done, right? Because they could just automate it. They go like, ooh, do new production at here. Whoop. They give us an IP range, we're done, right? And if we knock it down, who cares? Because it's not real production, it's just sort of production. We use Cloud Passage for a mole on a lot of our systems. We also have some mole-like agents we've used before. 10 minutes, I got it, thank you. And then Rack has been doing threat models with this additional metadata collection for a long time now. We have 68 of them or something. One of my coworkers actually had a really cool way to interlink them so you could actually kind of click through the various bits of our cloud. So our cloud server system talks to our identity system. You click on the identity system box in the threat model and it takes you to the threat model for the identity system. Oh, the identity system talks to cloud files. You click on that, you're now in the cloud files threat model, and you could actually sort of do the bouncing ball through our entire cloud infrastructure with all these linked threat models, which is really cool. And teams, like our BCP people went nuts. Like, holy crap, all this stuff is interconnected. Yes, it is, and here's a diagram. Have fun, right? They loved it. Securing apps and APIs. Our workflow, right? Somebody on the team finds an issue. We document it in our test tracker app. Those get pushed into ThreadFix. ThreadFix pushes them into a bug tracker. And then we have metrics driven off the ThreadFix database. So the manual bit is enter the finding, which you can't avoid. But after that, it's just done. Cron jobs in essence, right? We had some breakage with the nag script we're actually re-implementing as we speak. One of the guys is working on that. And pick a markup language that you like. I'm particularly fond of ASCII doc, but it really doesn't matter. Pick a markup language that you can gen into whatever you need for output. Because you'll be much happier writing plain text in the editor of your choice rather than having to do Microsoft Word in a VM because you use Linux, if you're like me. And then securing code, we use Veracode if the language is supported. It's self-service for the dev teams. We wrote and contributed the original Jenkins plugin that now Veracode has taken over. And then we use API automation to pull findings into our workflow. So instead of SE person, security engineering person finds one and puts it into bug tracker, it's call the API and we shove it into the bug tracker. Or we'll shove it into thread fix and then into the bug tracker. Right, but it's automated. And then we also have some automation. Actually, we're going to work on automation to do the same sort of nag script idea around Veracode, right? You haven't run a Veracode scan in how long? We need to go talk to you. I've already talked about the detailed finding blocks, right? We do hold trainings and e-learning modules for teams. We work daily with devs, and I've been loaned to the containers team since January of this year. So I'm 95% of my time in a dev team developing a product, which is a great place to be. And then we have dev days or hack days where we'll take half a day off on a Friday and work on automation. And that's been a fantastic thing. Highly recommend it, right? Because you're never going to get the chance to take the deep breath and work on paper cuts unless you iron out that time. And Friday afternoon is good because most people are like sick of work and want to do something fun. So that's a great little window. If you can get half a day on Friday, that's an awesome, awesome thing. Key takeaways, automate, 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 like find those paper cuts and make them go away. That is huge, huge win, right? Rinse and repeat, keep doing those. I fixed this paper cut, I found a new one, let's fix that one. Finding a workflow, like find and standardize a workflow so you can optimize the heck out of it. We're doing pretty good in this regard, it's kind of nice. And I have to do reports, or if I want to do reports, it's a database query and a call to Pandoc, right? Done. And create systems that can grow organically. This is hugely key, right? You may not have the final version ever, but as long as you have a thing that you can keep adding new checks to, you're golden, right? Because as you find them, like the grep tool for source code, just keep adding things to look for when you pull a code repository out of Git, right? It may not be sexy or all that awesome at first, but give it 6 months and it'll be actually really good, right? And you will never have that block of time that it took you to make that over 6 months in one single window, right? So organic, like systems that grow, I won't even start or consider a new system if we can't add to it organically over time because we'll never have that big block of time. Oh, and I talked about that. Finding blocks become templates over time. And if you don't already talk dev, learn to talk dev. That's hugely important. Oh yeah, whoever decides constant success must change his conduct with the times. Had to get a Machiavelli quote in. Right? It's just, I think it's a requirement somewhere. But that's it. Questions? Yeah. What we end up doing, that's a great question. The question was, what do you do for your longer running tests? I meant to say that, and I'm glad you asked it. So for the things we can do within the deploy window, we just do those. The things that are longer than the deploy windows, we figure out the cadence that works based on the team's cadence. So maybe they deploy every, like 2 times a week. Well, maybe our long-running test takes a week. So we just do those every other week, right? And yes, we miss some. We totally miss some. But hey, it's better than not doing it at all, right? So it's really team dependent and what their pace is. But you find that if you know the length of time that your long-running test takes and you know the cadence of the team, you can sort of pick that sweet spot where the window, if there was something missed, is as narrow as possible. Yes, sir. I like dumb questions. Oh, interesting. Okay, interesting. So the question was like face-to-face, remote, team dynamics, culture. How does that all work? Rackspace is uber casual. I'm dressed up more formal than I do for work right now, so that's kind of helpful. Rackspace has offices in San Antonio, Austin, Blacksburg, and San Francisco that do development work. So there is remote all over the place. And then the culture is pretty laid back. So for us. And the one thing, though, I would say is all of the security team works out of San Antonio. That's been huge because for the security people, we can sort of talk shop and help. And hey, I haven't seen Redis before. You did a Redis on a test, didn't you? Come over and give me a hand. Like that's much easier if you're all in the same place. But our teams are all over the place. I mean, like weird things like when you book a room for a threat model on a remote team, make bloody well sure the camera can see the whiteboard. Because I had one threat model where I had to draw everything like this, so it looked square for the people on the other end because the camera was at an angle. Right? Like those aren't cool things to find out when you walk into the room that you booked and go, oh God. And one time we have a lot of glass walls. the camera faced the glass wall, so I just did the dry erase thing on the wall, which was funny because somebody was on the other side trying to wipe it off at one point, which was kind of hilarious. So that racket works pretty good, and I don't know that it's so much like remote, or it's more about like the I don't know how to say this, like putting yourself in the shoes of the team you're working with, right? Because you're in essence saying, look, I found this really ugly thing, and it's not really my problem, it's your problem, right? And I can either lay this on your lap and walk away kind of snickering, or I can say, hey, here's this really ugly thing, let's talk about how we can fix this. And just be rational, right? You don't have to, like we had a couple interns over the summer, and they would find, say, cross-site scripting in an internal app that we use to book rooms. Well, that's kind of bad. But if you find cross-site scripting in like www.rackspace.com, that's like, oh, holy crap, right? And those different risks, but a lot of times the younger team members don't have that sense of context. Like, this is bad, and cross-site scripting is bad. But in this case, it's not as bad as this case. So let's be a little bit judicial about it and say, look, we need to get this fixed. I know you guys do 2-week sprints. Like, perfect example, there's one of the teams that came to me and said, look, Michael, one of our testers, found these 4 issues in our system. We were able to get 3 in this sprint, and there's 1 that we couldn't get fixed. And I looked at the specifics of the issue. It was particularly hard to exploit. You'd have to have a lot of domain knowledge that isn't really public. So I said, look, you guys do 2-week sprints. Launch, put this in your next sprint, right? I'll come back and test that last thing in 2 weeks. Like, I'm not going to lose my shirt or make you guys work the weekend for this one thing. Like, that kind of mentality. And now that team loves us, right? Because they can have rational conversations about how we fix things, and we're not the like crazy security people who, rain hellfire and brimstone on them, right? Yes, way in the back. He's a plant. Yeah, and like a perfect example of this is one of the times that I did a little happy dance after the team left, or this one guy from the team left is, there was one team that we'd worked at, we'd done an engagement, it was a pen test and a VA plus an API test. We get done with them, we found some stuff, we worked through the issues, great. 2 months later, they come over and say, hey, we want to do this kind of spooky, weird thing, and we think we want to implement it this way, but we're not sure. I'm like, cool, whiteboard over here, let's go talk. And this is like when they're in the paper napkin stage of designing this thing out. They're coming to us to ask for our opinion. Like, huge win, right? That was a very happy moment in my rack career. Yes? Yeah, this question, thank you. I love your, thank you, the subtle hints of like, say the question. How do you, say that again, because. How do you coordinate pen testers to be effective in that environment? Luckily, all of our pen testers are internal, and it's just a matter of, for our pen testing particularly, those tend to happen in products that are launching in what we call, I don't know what we call it, we would give it a name, but preview. It's before customers get on it. So we have access to a real production environment, but there are no customers. So that's like the sweet spot window. But for some of them that are so big, like compute is a silly number of hosts, we do sampling, right? Let's take, in this DC, there are n number of things. Let's divide n by a rational number so we have a decent size and check those. And then if you get variations, then maybe you dig more. But if they all come out the same, okay, good, their automation is fine. I don't have to worry about it, if that makes sense. So a lot of times because of the automation, your pen testing actually gets easier. Because if I looked at node 1 and node 2 also looks the same, I really don't need to look at node n. Or I might sample a couple of them, but I really don't have to look at the whole IP range, which is hugely valuable. Yes? How do you measure the effectiveness of different security activities that we do? One, we generate reports that managers ask for. I don't know if that's effective or not, but we definitely do that. 2, Some of it is subtle. I mean, some of it is just like, honestly, teams approaching us proactively. That's a huge thing. But more of it is like, how many times do we hit those neg script things, right? How many times are teams busting the SLAs? Gives you a really good idea of how effective you are at either communicating and sort of working with those teams, right? If consistently we drop a bug in their bug tracking system and we have to go hunt them down and argue with them, we're failing somehow, right? And that's sort of our metric. Like, how much friction we have to get things fixed is a good metric. And we generally measure that by how many times we're bumping up against that SLA. Oh, interesting. I don't know that we have any metrics to that. Like how long, but like if we launched on October the 1st and we find it on the 7th, that's 7 days. Yeah, I don't think we track that at all, to be bluntly honest with you. We could maybe tease that out somehow, but we never have. Yeah, yeah. I'm sorry, one more time? Do we do design security review? Yes, we do. We call them, I can't remember what, architectural analysis. I can't remember what the Kevin on our team who does all of those, what he calls them, but yes, we do those as well. And like perfect example, before Kevin and I was doing them, our Hadoop product, before it was launched, not the one that's in production today. But the way they did it is each customer would get a whole bunch of nodes that would do the heavy lifting and the storage for Hadoop. And there was one node that was shared that would do all the HSQL, the SQL-ish stuff for Hadoop. And we were doing the threat model, I'm drawing this out, and I realized like choke point. And I said, wait a minute, like I just need a credit card, right, to buy from Rack. Like I don't need intelligence. And they were like, yeah. Okay, so I have a Visa card that has enough balance to get me a Hadoop cluster. Like I could write really stupid HSQL queries, can I? And they're like, well, I guess so. I said, so I could like tie up the CPU or knock out this node. Well, I guess so. And I'm like, well, when I do that, I not only impact me, I impact all customers. And they went, oh God. And I went, yeah. And so we actually like stopped the meeting. They went off and redesigned and came back and they'd abstracted all that away and done, right? So yeah, we've done that, and that's a huge win when you can catch those early. Because if we'd launched that, like, oh my God, fixing that would have been a nightmare. Yes. Any more questions? Yes. A separate test org. I report up through the VP of Quality Engineering. So not for me, but yes, we do. Really well, because we're all part of the same org, and actually they have for OpenStack, there's this thing called Cloud Cafe, or Open Cafe, whatever we called it, that is a testing framework for OpenStack. We've actually introduced fuzzing and other tests into that framework so that now the QE guys just do the fuzzing work for us, right? So yeah, like being friends with QA or QE or IVNV or whatever you want to call them, huge win. Like be nice to those people. Because there's way more of them than there will be you, period. Like learn to also be friendly with those guys. Cool. Well, thank you very much. Thank you for making the last talk.